something to it. So right here, you don't have this, I don't believe, in your notes. It just says, or that's just not there. But we added this right there where t is greater than or equal to 0 um, because we don't care about the time before that. So that's something that we're just added to the notes. T is greater than or equal to 0. So we only care about when it starts and moving forward. So the position, it gives us the position, S or f of t, either one of those. You won't always see both of those, but either one of those could be given to you right there for the position function. And then it tells you as seconds in meters. The first thing is to find the velocity at time t. So the velocity is the derivative. We could write that s prime. We could write f prime of t, or we could write v. You don't have to write them all, okay? Any of those would be acceptable for this problem to answer what it is. So, because it gave us s prime, it gave us f of t, f prime of t, or velocity, just v, not v prime. It's going to be something else later, just v. So we find the derivative of that. So the 3 comes down using our power rule, t squared, again our power rule, minus 12t plus 9. So adding and subtracting, you take the derivative of each of those. That's different than multiplying and dividing. We can't multiply and divide, take the derivative of the top, take the derivative of the bottom, or derivative. We've got our power, our product, and quotient rule that we learned on Friday. We can't do that with multiplying and dividing, but we can with adding and subtracting. So there's number 1. We found the velocity at time t. Then it says, what is the velocity after 2 seconds? So all that means is we would plug in 2. So f prime of 2. So 3 times 4 minus 24 plus 9. So what is that? Negative 12 plus 9. Negative 3 meters per second. That was our second question it asked right there. When is the particle at rest? Okay, so that means when is the velocity 0? So we want to know, when does v equal 0? That means the particle is at rest. It's not moving forward or backward at all. It's stopped. So we take the velocity and we set it equal to 0. 0 equals 3t squared minus 12t plus 9. Now, as far as work goes on this one, because it's an equation, we set it equal to 0. We could divide by 3, or we could factor out of 3. Whichever way you want to do that. You don't have to, but it makes it a lot easier to factor if you make it smaller, so that, we get t squared minus 4t plus 3. Again, because it's an equation, we could have just divided by 3, and that would have been okay. You never want to divide by letters, but dividing by numbers is okay because it's just a scalar. It's just multiplying it, making it bigger by 3 times or smaller by 3 times, whatever it is. And we get minus and minus. So at t equals 3 seconds and 1 second, that would be when the velocity equals 0. It doesn't. I mean, if I didn't pull it out, I would have gotten, what, 3t minus 9, t minus 1, and this would have still been t equals 3, and t equals 1, okay? And again, because it was just a number and it was equals, I could have divided by 3 on both sides. It was equation. As an expression, I can't do that, but in equation, I can. Now, sometimes it'll say explain why, or justify your answer. Okay, the justification for this would be because f prime of t equals 0. That's your justification. You will see a ton of justifications like this right here. Always talk about the velocity, or when we get to acceleration or the position, whatever it is. If it said it doesn't, but it could. That's the justification right there, because f prime of t equals 0. All right, next question, when is the particle moving forward? Okay, when is the particle moving forward? So that means the velocity is going to be positive. Okay, so forward means f prime of t is greater than 0, or is positive. Okay, f prime of t is positive, or f prime of t is greater than 0. That's when it's moving forward. Or it could be to the right. Forward and right would be positive. Backward or left would be negative when we're explaining about movement, something like that. So we've got to figure out, when is this velocity positive? So a sign chart's what's going to help us do that. We know, okay, so we know we can't go past 0 because the original problem said t is greater than or equal to 0. So we don't care about anything to the left of 0. We know that it equals 0 at 1 and at 3. So doesn't go past 0. This is where the velocity is 0, velocity is 0. So these three are going to have a sign, a positive or negative sign. So however your teacher taught you to do your sign chart, you can do your little parentheses. If they showed you your little parentheses, maybe you can do it in your head, or because it's t is in the front, to the left of the number is negative, to the right of the number is positive. Again, however you do that. So if I plugged in a 0.5, I would get a negative. A 0.5, I'd get a negative. So that section is positive. I don't have to see these little parentheses. I just want to know, is that section positive or negative? However you come up with that. If I plug in a 2, I get a negative and a positive, so that section's negative. If I plug in a 5, I get positive, positive, so that section is positive. So that's what we're looking at. So again, the question, when is it moving forward? Okay, well, it's going to be from 0 to 1 and from 3 to infinity. And if it asks for a reason, because f prime of t is greater than 0, f prime of t is positive. Again, if it asks, a lot of times it will ask. Not always, but it could. No, because at 1, it's equal to 0. So we don't want to include 1 in that. At 0, it's at nothing. We haven't done anything. Okay, and if we include the 1 and 3, then that means we're including a 0 in there. And we know for a fact that it is 0 at 1 and at 3. So that's why we have the parentheses. And if you want to put the u in there, the u in there is fine. I don't know why in calculus it just goes away. It doesn't matter. It's not wrong to put it there. It's just usually you don't see it there. If it said backwards, it's going to be moving backwards from 1 to 3, again in parentheses, because at 1 and 3 it's 0, so it's everything in between 1 and 3, it would be moving backwards. All right. The next question, draw a diagram to represent the motion of the particle. Okay, so we're drawing a diagram off of this sign chart, the motion of it. When is it going forward and backward? All right, so 5. All right, so we have from 0 to 1, it's positive. So I'm going to go ahead and just do 1, 2, 3. Okay, and then we know from 3 it's going forever. So if it's positive, if the velocity is positive, the velocity is the slope of the tangent line, so that means we have to draw a picture whose slope of the tangent line is positive, then negative, then positive, but also the slope of the tangent line at 1 and 3 is 0. So that means at 1, it's going to curve. So it's got to start at 0. It doesn't matter where you start at 0. We don't know where we are at 0, so it's got to be a slope of the tangent line is positive going up to 1. And then it's got to be negative going down to 3, and then it's got to be positive. So at 1 and 3, it has to change direction from positive to negative, from negative to positive. From 0 to 1, slope of the tangent line is positive. 1 to 3, slope of the tangent line is negative. This is the sign chart for the velocity, slope of the tangent line. And then from 3 on, we'll go ahead and put an arrow because we know it goes on forever. From 3 on, it is positive. And it wouldn't matter where you are on that. I mean, because we don't know anything else. All that matters is the slope of the tangent line. It doesn't matter if it's up above, below, who knows where it is. All that matters is that we are looking at the slope of that tangent line. It doesn't matter where it is on your coordinate plane. Find the total distance. Okay, total distance traveled by the particle in the first 5 seconds. All right, so remember, the particle starts at 0 and it travels forward, then it travels backwards, then it travels forward. So we want the total distance forward and back. So we have to add all of these sections up, and then we're going to have an endpoint of 5 right there. So if we want to add all those total distances up, now we're back to position. How far did it go? We don't care about how fast it's going anymore. We just care about how far it's going. So we want to know the distance. So that's just going to be the absolute value of whatever the distance is between 0 and 1, between 1 and 3, because again, we know what happens there, and then we have this other point between 3 and 5. Because we went forward, backward, forward, we have to do those 3 sections. So it's the absolute value of the position at 0 minus the position at 1. Or 1 minus 0. It doesn't matter because we're taking the absolute value of that. It doesn't matter which way you do that. And our position function was t cubed minus 6t squared plus 9t. So that's what we're plugging into right there. Then we need the position from 1 to 3. And then we need the position from 3 to 5, because it said the first 5 seconds. So, because I have to find the distance. From 0 to 1, 1 minus 0. So this distance right here is going to be this minus this or this minus this. Since it's the absolute value, it doesn't matter which one you do first. Okay? So if we plug in 0, we get 0 minus 4. So that gives us 4. If you'd done s of 1 minus s of 0, 4 minus 0, you'd still get 4. It's the absolute value, total distance. All right, and we know s of 1 is 4. 3, we get 27. And 27, so that outside is 54. And then negative 6 times 9 is 54, so that's 0. So plus 4. And again, we already found s of 3. That's 0 minus, we need s of 5. So 125. Minus 6 times 25, so 150, plus 45. So we get negative 25 plus 45, so minus 20. Absolute value of that is 20. So we get 28 meters. Now, this question wasn't asked. But it could, so that is total distance. It could ask the displacement. Displacement is another thing it could ask. So if I start here and I walk forward and backwards and forward, then I don't care about that backwards part. I just care about beginning to end. So if I'm talking about displacement, the displacement is end minus beginning. Where were you at the end versus where were you at the beginning of that? So 20 minus 0, because if we started at 0 and went to s of 5, 20 minus 0, that would be 20 meters. because we didn't care about the back and forth. We just cared about where we started and where we finished. And could the displacement ever be zero? It could, because you could walk however long, but you could end up right back where you started, and the displacement could be zero. All right, so that is the last